Hello, my name is Leo Lamb and this is my Project 1 for the Design and Manufacturing course at Georgia Tech. This project requires improving upon a product that is used in everyday life. To address this prompt, I created an attachment for air vents. Here's a brief overview of what I'll talk about today. So, what is the existing product and how does it work? Air vents direct air from the air conditioning unit into the various rooms of a house or apartment. They typically have dampers that direct air both horizontally and vertically, as you can see from the figure on the right. They're typically screwed directly into the wall and are frequently mounted high up in a room. The problem with current air vents is the lack of flexibility. Typically, there is only one central AC system that controls the airflow and the temperature of the entire house. However, whether it's living with family or with roommates, most people have different preferences for how much air their room receives at various times of the day. For example, one roommate might prefer it colder at night since it's easier to sleep at night when it's colder, or they just generally prefer colder temperatures and more airflow compared to another roommate. Some vents have adjustable dampers that let you control the airflow into the room, as you can see by the lever on the figure on the right. However, as previously mentioned, these vents are typically high up in a room near the roof, which requires a user to stand up on a chair or some other elevated device in order to reach the vent to adjust the airflow. This is especially annoying for those that like it to be colder at night but less cold throughout the day, as they would theoretically have to stand on such elevated device every morning and night in order to adjust the airflow to their liking. So, what's the solution I came up with? I created an attachment that magnetically attaches to existing air vents and allows users to customize their airflow for their room and time of day preference. This attachment is easily removable since it simply uses magnets to stick onto existing air vents without any tools, making them renter friendly, unlike current air vents where you have to unscrew and rescrew the vent if you want to change it. As the figure on the right shows, you can simply attach it right over your existing air vent. There are interior dampers that are powered by a motor that is controlled via a mobile application and Bluetooth or Wi-Fi. This enables users to control the airflow without having to grab something all the way to reach up to the vent. They can simply change the airflow on their phone. This attachment would support all of the standard vent sizes and would simply be powered via a USB-A port that connects to all standard wall warts. Here are the graphics and CAD for the concept. This gives a good view of the front of the attachment. Everything is housed within this frame that hugs up right against the vent or wall to avoid airflow loss. There are both horizontal and vertical dampers, and the power cable sticks out of the bottom of the frame. This is the back view of the attachment and gives a good idea of everything that's happening. Firstly, you can see these 4 magnets that allow the attachment to seamlessly attach onto an existing vent. These horizontal dampers are connected into a 4-bar linkage-like system that is driven by a rotary motor, which opens and closes these dampers. The electronics consist of an Arduino with Wi-Fi and Bluetooth capabilities, and also a motor controller. There's a plastic box that goes over all of these electronics with cutouts for wires to prevent damage and minimize accidental contact from the consumer or anything else with any of the electronics. Here's an animation demonstrating how the attachment and motor would open and close the dampers to control the amount of airflow that the room is getting. As you can see, there's the dampers opening up to allow more airflow, and the motor is spinning, which opens up the dampers. And it turns the other way to prevent the air from flowing. Now, how can this attachment be manufactured and what materials would it take? Most of the components are off the shelf, including all of the electronics, the magnets, the motor, and the fasteners, so none of these components will require any additional manufacturing or adjustments. There are 4 main parts to manufacture. The frame is essentially a box with an open side and some extra geometry to help house everything. So, injection molding would be an easy way to manufacture it. The electronics cover is essentially the same base geometry, with it being a box with an open side, so injection molding also makes sense for it. Typically, dampers are made up of sheet metal, A punch and die can shear a slab of sheet metal, and the rest of the cross-section can be cut out. Then the side tabs with the holes seen on the figure on the right can be bent into shape. The damper rotor, which is the piece that's connected to the motor, it has pretty simple geometry with essentially two cylinders of different diameters. So this can either be die cast or a pipe could be cut, and then the cylinders could be either milled or lathed to get those different diameters. As for materials, the frame and electronics should be made out of polypropylene, as it's a thermoplastic polymer with high heat resistance. This is important because the AC can also blow hot air, so we want to make sure that the attachment doesn't get affected by this. The dampers are typically made out of aluminum, but plastic dampers do exist as well for price reasons, although it's commonly seen as unaesthetic. If they were to be made out of plastic, polypropylene would work here for the same reasons. The damper rotator would preferably be made out of metal to minimize long-term wear between the motor shaft and the connection area. Aluminum should be strong enough for this piece while not being too expensive. Conclusion. Here are my pros and cons for the design. As mentioned earlier, this enables users to adjust on demand each individual room in the house to each other's likings at various times of the day. It requires no installation, making it both user-friendly and renter-friendly. Some disadvantages include that it could be aesthetically displeasing for some consumers since it's not flush against the wall like current air vents. It'll stick out a bit. Furthermore, it can be quite pricey considering the electronic parts chosen and also depending on the materials. For example, choosing aluminum dampers might improve its longevity versus plastic dampers, but it would definitely increase the cost as well. Finally, there is no manual adjustment option currently on the design, meaning that if Wi-Fi or Bluetooth goes down, the dampers can't be easily adjusted. This is definitely something that would be accounted for in future designs if this project was taken any further, though. In summary, this product improves upon traditional air vents for two main reasons: ergonomics and customizability. Magnetic attachment lets it be super easy for users to install, use, and move. Motorizing the dampers heightens the ease of use for consumers, as they can have the control of the airflow in any room of the house at any time, and also schedule routines and certain times for the dampers to automatically increase or decrease depending on the time of day. Here are the references I used. As a disclaimer, this product was made for educational purposes and does not resemble any existing product or patent to the best of my knowledge and research. Thank you.